Let's create example 2.4. You can either copy example 2.3 and delete a lot of things, or well, go ahead and just copy example 2.3 and name it 2.4. So I'm going to do that to file, save as example 4, and going to get rid of everything except making the data. Okay, so this is where I'm at. I have this data. I'm going to go ahead and, just for simplicity on this model, I'm going to bring us back down to 20 data points, right? Because ridge regression is more helpful when you have a sparser set of data, because you can make more corrections to your cost function that way. Now, I'm going to go ahead and create my x underscore model, and that's what I want to build over, and that's np dot linspace -3, number equals 100, and that should show up just fine in my variable explorer. Okay, so that's 100 comma nothing. So I need to add a dimension to it. X underscore model is equal to np.expand dimensions x underscore model comma axis equals 1. And now it should be, there you go, 100 comma 1. So that looks much better. So let's go generate or perform linear regression, or ridge regression. So we're going to do this in a for loop. All right, so I've got plt.figure, plt.grid, true, plt.scatter, x comma y comma label equals data. Not sure why that tried to put that in. I'm going to go color equals gray. All right, now I'm kind of back to where I was before. And let's go ahead and do we want to do 3 different ridge regressions for 3 different alphas? That kind of makes the most sense. So let's go line underscore style. Well, here, let's not do it that way. Let's try to do it. Let's just try to do it straight. So let's go model is equal to sk.linear underscore model. So we're back where we were ridge, and that's going to be pulling up the ridge linear model for alpha is equal to, just say 1. That gets us pretty close to just basic linear regression. We're going to go solver. You have to pick a solver. I don't remember what the auto one is. It might be Cholesky anyways. But I'm going to explicitly call out the Cholesky solver. And then model.fit x comma y, and then y underscore model is equal to model dot predict x underscore model. And that should predict my model. That needs to be a capital X. Should we hit F5 and see if it runs? Okay, perfect. No errors yet. plt.plot x underscore model, comma, lowercase y underscore model, comma, all right, let's see if that gives me a linear regression kind of right through my data. Now I need at least an x and a y, right? plt.x label x, plt.y label y. All right, so there's linear regression, actually solved using the closed format, because that's just what sklearn pulls from for linear model.ridge. And now if I increase my linear regression term, my alpha value, this line should become more parallel. So let's go an order of magnitude up. Maybe it's more parallel. It's a little hard to see. Do 100. All right, now we're getting more parallel, and 1,000. Right? And again, that is regularizing the model, so it's not responding to the data as much and kind of looking for a lower order path through the data. All right, so let's do one. So let's call that perform linear regression, perform ridge regression for linear model. And now let's do one for polynomial model. All right, so again, we're gonna copy over setting up my figure, and I'm gonna go ahead and copy over my X and Y labels this time. Now I have a new empty figure, so let's go ahead and create a polynomial model for this one. So let's go model is equal to sk.pipeline dot make underscore pipeline And now we're going to build up a pipeline of things. So first is sk.preprocessing dot polynomial, capital P, polynomial features with a capital F, 10, comma, I'm going to kick that down to the next line. There we go. And then we're going to go sk.linear underscore model dot ridge, and alpha is equal to I, comma, well, let's not do that. Alpha is equal to 1. First, we'll start with a very non-ridge model. Solver is equal to, again, auto would probably work, but we'll go Cholesky, just so we're all on the same model. Should hit F5. All right. Has no feature pipeline. Okay, so I probably need to import from sklearn import pipeline. All right, now it solves without an error, so that's good. And then let's go, we've built our model, let's train it, model.fit, capital X, comma, Y. Y underscore model equal to model.predict X underscore model. plt.plot X underscore model, comma, Y underscore model, comma, line underscore style. Oh, we don't want that, sorry. That should be all I need. Okay, so that's actually not a bad model, but I'm only interested in a little bit of this. So we're going to go plt.ylim from -1 to 10. plt.ylim from -1 to 10. And maybe that wasn't enough. Maybe we need to go, oh wait. Oh, -1, sorry, I lost my negative. All right, there we go. So there's a nice polynomial model, right? Basically, so let's see what happens when we slowly up the ridge regression on this. Let's go 100, because 10 on the last one didn't do a lot. And so 100 gives us a nice cleaner, a much cleaner model. Maybe we don't want it quite that regularized, though. Maybe we want it a bit less, so we can go 50. And now it responds a bit more to the data, right? So essentially what we can build here, what we can use ridge regression for, is another parameter, another hyperparameter that we can use to kind of help it respond to the data. So when you're working on your machine learning projects, this is an excellent thing to do, right? Because not only does it show, you know, your customer that you understand your data, but it shows your customer that you understand maybe how important your data is or what type of model you're looking for, right? Like if you're looking for, you know, your customer may just be looking for a linear model because that's what they want to, say you have a chemical process and that's what they want to design a chemical process plant around, right? They may not want to make a plant that has all sorts of bumps and ridges in it. Maybe this data out here is something that they collected at the 2, right? So at x equals 2, maybe they collected this data just kind of for an experimental purposes, but all of the manufacturing happens between like -2 and 1. So they're really just kind of looking for a good fit model in between that, right? But they have some edge cases to kind of help build out the data set. So that's ridge regression. Again, the idea is just to add another hyperparameter to let you kind of adjust the importance of data. Any questions on ridge regression? Any questions on anything? It's very quiet today. Get in there. Yeah, who's got it working? Okay, so just Lathan. Richard.
I'm getting a model map.
Invalid syntax model. No, you might have something wrong with the line above it. You created a pipeline, but you haven't closed it. I bet you need another. There you go. And now it closes out your pipeline. There we go.
I'm getting it.
Matplotlib has no to predict. Yeah, that's not what you want. Where you got matplotlib, you want sk.predict.
Where?
Model
SK.
72, line 72, plt.predict. No, you want plt.plot.
Oh.
Matplotlib is plotting.
That much, that's fine. Yep, there we go.
There's no something, it's wide limb. You did exactly what I did. Which is fine, yeah. I mean, I'm the one who made the mistake.
Oh.
Perfect. Oh yeah, go from -1 to 10, so you can see it.
Thank you.
Yeah, that looks good. Oh, you put them both on the same plot.
I forgot that.
No, I like that. I'm gonna change my example. That's a good idea.
Thank you, unintentionally.
Good. Is it working? Yeah. Something. Oh, that's a great model. What's your alpha set? 50,000. That's awesome. So no, that's before we move on, go ahead and set your alpha to 50,000. And that's really probably what we should be doing, right? Look at that beautiful model. You may be running a manufacturing process, and this is like the order of the model that you want. Does that make sense? Right? This is the level of complexity and the level of sensitivity you want to individual data points. So this is actually a really good example of ridge regression. That model is definitely not overfit, and depending on what the data out here looks like, that might actually be a very good representation of that model, of that system.